This is my beginning algebra course. In the next class, you're going to take test number 4, and today we're going to prepare for that test. If you haven't done the homework completely and correctly from the last class, do that homework before watching this video. As I mentioned in previous classes, you cannot take a math exam and pass it unless you study for the exam. Doing the homework and the class problems will prepare you to study for the exam, but it won't prepare you for the exam. You have to do additional studying, and usually studying intensifies right before an exam. And that's when students generally develop a bad attitude because they really don't like having to, intensify their studying habits right before the exam, but that's just the way it works. You need to make sure that you know how to do all the problems that we went over in the last 2 or 3 weeks, and there's even some math that you're going to have to know that we covered in the last, however many weeks, 10 weeks. Now, it doesn't matter how many times you tell students to study for an exam, they're not going to do it. So I'm going to give you a practice exam for homework, and we're going to do a practice exam right now, and the homework exam is going to force you to do at least some studying for the test. It's not going to guarantee that you get an A, but hopefully it'll at least ensure that you pass the test. If you want to get an A, you got to, again, go back and make sure you know how to do every single type of problem. Look at your the class, the screenshots we took of all the classwork that we did, and go over your homework. Make sure you know how to do every single type of problem. That'll ensure that you get an A. Now, again, like I mentioned in previous classes, there are 2 reasons for these practice tests. Number 1, to give you an idea of what my tests are going to be like, so you can't take test number 4 and say, well, I didn't know it was going to be like that. And number 2, to force you to study for the test. So let's get into it. Now, as in previous practice tests, I want you to attempt these problems on your own. Don't just watch me do the problem if you already know how to do it. So if you think you can do this problem on your own, go ahead and try number 1, and when you come back, we'll do it together. If you are not sure how to do this problem, we'll go ahead and I'll get you started. But as I'm doing this problem, if you start to remember how to do it, don't just watch me do the rest of the problem. Stop the video and do the rest on your own. You're going to absorb this information with much greater efficiency if you do the problem on your own. So here we go. We're identifying the different forms of linear equations. And part A, we have parentheses here, so that's a dead giveaway that this is point-slope form. So I'm going to abbreviate point-slope form. And we have an equation with both variables x and y on one side of the equation, so that's going to be standard form. And over here we have y isolated. It's by itself on one side of the equation, so that's a dead giveaway that this is going to be slope-intercept form. And over here, again, we have x and y on one side of the equation. That's a dead giveaway that it's going to be standard form. So if you got those answers right, good job. Those were easy problems. We were just identifying the form of the equations. So now we have a word problem that's going to turn into a system of equations. Stop the video, see if you can do this, and when you come back, we'll do it together. All right. So if you're not sure how to do these problems, let's go ahead and read this. It says, there are ducks and geese on a pond. The difference between the number of ducks and the number of geese is 21. The number of ducks is 2 more than twice the number of geese. How many geese are on the pond? All right, so the first thing we need to do is define our variables. Now, obviously, we're going to use D for ducks and G for geese. You could use X and Y, but why would you do that? It's easier to use G and D. So I'm going to use G, but what is G and D, what are they going to represent? That's the first task on these problems, is what do G and D represent? Well, that's easy. The blue tells us. Whatever the problem is asking, that's what our variables are probably going to represent. So how many geese are on the pond? Well, G represents the number of geese on the pond. All right, and of course D is going to represent the number of ducks. So all we have to do is just look at that that statement that asks us what we're looking for. So now we're going to come up with some equations, and the yellow statement up there gives us a really easy equation. On a lot of these word problems where we're trying to find a system of equations, there's oftentimes one equation that's really easy, and that's the yellow equation. The difference between the number of ducks and the number of geese is 21. So difference means subtraction. So if you subtract the number of ducks and the number of geese, you get 21. So that's the first equation, easy. Now a lot of students would say, wait a second, how do you know it's d minus g? How do you know it isn't g minus d? Well, the answer to that is pretty simple. Do you see how ducks comes first in the sentence? If ducks comes first in the sentence, then that means that d comes first in the equation. So that's just the way that it works. Okay, so now we're going to come up with the next equation. That's going to be the purple equation. The number of ducks equals 2 more than twice the number of geese. So this green expression here is twice the number of geese, and this means there's 2 more than twice the number of geese. So that is the system of equations that we're going to use to solve this problem. And I'm trying to make a bracket there, but there we go. We have to connect those two equations with a bracket because, again, it's a system of equations. Now, there are 3 ways to solve systems of equations. There's substitution, elimination, and graphing. Remember, you never use graphing unless you're forced to use graphing by your teacher, because graphing is impractical. It's hard to use. It's not very reliable. You have to have graphing paper, and even if you do have graphing papers, sometimes it doesn't really produce the answer. So you never want to use the graphing method if you can help it. So the question is, do we use substitution or elimination? And for this problem, we're going to use substitution. Why is that? You can use either method, elimination or substitution, for any problem with a system of equations. But substitution is going to be easier. How do I know that? Because one of the variables, this orange variable here, d, is by itself on one side of the equation. D is isolated in that equation. That means that d, on the left side of the bottom equation, there's nothing else around it. It's by itself. Whenever you have that situation, substitution is probably going to be the easier method to use. We could use elimination, but substitution is going to be easier. So what we're going to do is we're going to take the other equation where a variable is not solved for, and we're going to rewrite that equation. But instead of d, we're going to write what the bottom equation tells us d is equal to. I wrote d here. That's d. And the rest of the equation, that was this part here. So hopefully this highlighting helps you to see, where I got all this stuff. Hopefully it's not confusing you. So I plugged in all this stuff into d. Okay, so now we have an equation with only a g, so we can solve that. 2g minus g is g. Subtract 2 from both sides, and we get g is equal to 19. And you probably want to write a final statement. The final statement is going to be we have 19 geese. I want to make room for that final statement. So you can say 19 geese, because we have to have units. This is a word problem, so we have to have units for our final answer. So if you got that answer, good job. Okay, so let's go on to number 3. If you think you can do these problems, go ahead and try number 3. And as I'm doing this, again, if you start to remember how to do these problems, stop the video and do them yourself. Don't just watch me do them. So the most important thing to understand here is we have the y-intercept. It's right there. We know that the y-intercept is 1, 2, 3, 4, 5, 6. It's 6. And remember, the y-intercept is where the line crosses the y-axis. This is your y-axis. The line crosses at 6. And we also have another point here, and we can use that point to find the slope. We have rise over run, you see. So if we can see the y-intercept and the slope by looking at the graph, then that means we're obviously going to use slope-intercept form. Slope-intercept form is y equals mx plus b. Okay, and maybe I should go ahead and write the y-intercept first. So we know that the y-intercept is, maybe I'll write it down here. Well, we'll see. So y-intercept is 6, and the slope we're going to find is up 1 and over 1, 2, 3, 4. So it's 1/4. The slope is 1/4. So we're going to use slope-intercept form because we can just plug those numbers in to that equation. So I'll bring that over here. You don't have to write this stuff if you don't want to. You can just write the equation, but I'm trying to show you how I'm doing this. So now the slope is 1/4, and the y-intercept is 6, and you're done. All right? So it's that simple. So if you got that answer, good job. Let's try part B. Now for part B, we cannot use the slope-intercept form. Why is that? Well, because, look, we don't have a point that's at the corner of a square. You see, this point was at the corner of a square. We had that red dot there. We know that it's going to be 6 just by looking at the graph. But here, we don't know what this is. It looks like it's going to be 1/2, but you can't just assume that it's 1/2 because it looks like 1/2. That's not how math works. It could be a little bit above 1/2 or below. So we can't use the slope-intercept form because we don't have the intercept. So what we have to use is point-slope form. Point-slope form is y minus yp is equal to m times x minus xp. And we're going to use the slope. So let's figure out what the slope is. We need a point, and we need the slope. The point is going to be xp and yp, and the slope is going to be m. So we need the yellows and the purple. So we have plenty of points. We have 2 points. We only need 1 point. But we need to find the slope. So we're going to start with 1 point and go down 1, 2, 3, 4, 5, 6, 7, and go over 1, 2, 3, 4, 5. So that's 7/5 is the slope. So I'm going to go ahead and plug in 7/5 for the slope. And already I've made a colossal error. What's the error that I've made? Well, this line is going down from left to right. So it's not enough just to write 7/5. I have to write negative 7/5. So be aware that a lot of students forget if a line is going down from left to right, you have to write a negative. So now we can use either point. Do you want to use this point, negative 1, 2? Or should we use this point over here, which is 4, negative 5? Which point do you want to use? Well, I'm going to use this point up here, but you can use the 4, negative 5 if you want. So y minus 2, and it's going to be x plus 1. I don't have a lot of room to show the math behind that. But a lot of students are going to say, wait a second, you reverse the signs. Okay, the y value is positive 2, so it should be y plus 2. And the x value is negative 1, so it should be x minus 1. Well, remember, the signs reverse when you plug into this equation. So the signs should be reversed. That's just something that you need to memorize. And why is that? Well, it's just because this equation has subtraction symbols. If you're going to subtract a negative, then it's going to become a positive, you see. So now, again, your answer might be y plus 5 is equal to negative 7/5 times x minus 4 if you use this point. But either one of those answers is fine. So if you got that answer, good job. So that's point-slope form. We use that form when we don't have the y-intercept, but we have points and we have the slope, or we can find the slope. So on to these next problems. Go ahead and try these if you remember how to do these. We have a horizontal line, and when you have a horizontal line, the equation is always going to be y is equal to whatever, wherever that line is at. And we see it's at 1, 2, 3. So it's y is equal to 3. Now, why is that the equation? Well, because all these points on this line, they all have a y value of 3. It doesn't matter what the x value is, the y value is 3. So mathematicians have decided to just notate this equation as y is equal to 3. It's always equal to 3. So if you got that answer, good job. See if you can do part B. When you come back, we'll do it together. All right, we're back. So this equation is going to be x is equal to negative 1 because the line is at negative 1, and all the x values of all these points on the line have, all the x values are negative 1 of those points. So that's why we notate that, or we write the equation as x equals negative 1. So if you got those answers, good job. All right, on to number 5. It says, for each problem below, write an equation of the line with the given characteristics. There's more than one way to write the answers, but try to use the method that is quickest. All right, and that's what we're going to do. We're going to use the quickest method. So it says here, we have to write an equation of the line that has these characteristics. The x-intercept is 6 and the slope is 4. Now, remember, if the x-intercept is 6, that means that the line crosses the x-axis at 6. So what that means is that that point is 6, 0. The y value has to be 0. That's what it means to cross the x-axis. If the point is on the x-axis, the y value has to be 0. All right? So that means that we have a point. We have the point 6, 0. And we also have, of course, the slope. They tell us the slope is 4. Now, we have a point, and we have the slope of the line. Point, slope. Okay, we have point, slope. So obviously, you're going to use the point, slope form of a line. Now, again, remember, there's slope-intercept form, which is y equals mx plus b. There's point-slope form, which I just wrote over there. And there's standard form. Standard form is the one that's not really very useful. So there's 3 forms of a line. The names of these forms tell you if they're going to be useful for you to use. Slope-intercept, if you have the slope and the y-intercept. Point-slope, if you have a point and the slope. So we have a point and the slope, so obviously we're going to use point-slope form. Why are we going to use that form? Well, because we can just plug in the answers. You see, we just plugged in the yellow 0, and we're going to plug in the purple 4, and we plug in the green 6. So it's so easy to find the equation. And we're done. Now you can simplify that if you want to and get rid of the 0, but it's also fine to leave it like that. So again, it's so important to understand that the names of these forms here, slope, intercept, and point slope, are clues to tell you what form is easiest to use. Now you could use the slope intercept form also. You could say y is equal to mx plus b, plug in 0 for y, 4 for m, and 6 for x, and then solve for b. Once you find b, then you know the slope and b. You know m and b, so you plug in m is 4 and b is, what would that be, negative 24. All right, so you can do it that way also, but the problem is this way requires all kinds of mathematics. You don't want to do that. You just want to plug in the answer and get it done as quickly as possible, you see. So if you got the other answer, that's that's fine too, but you're just taking the long way. So y equals 4x minus 24 is also acceptable. Okay, now we have the x-intercept and the y-intercept. If you want to try this problem, go ahead. If you're not sure how to do it, I'll get you started, but once you think you know how to do it, take over. So the x-intercept we have, and that's 3, 0. Again, that's what it means for us to have the x-intercept, is the y value has to be 0. And we have the y-intercept, which means the x value has to be 0. Again, based on the logic we were talking about before. If your y-intercept is 9, then that means it's on the y-axis, and of course that means the x value has to be 0, you see. So now we have 2 points, and we're trying to find an equation of the line that goes through those 2 points. In order to write the equation of a line, you need 2 things. You need a point, which gives you a starting place, but you also need direction for the line. The slope's going to give us direction. Problem is we don't have the slope, so we're stuck. So what we have to do is we have to use our slope equation given 2 points on a line. So that's the equation. And in order to figure out what's going on here, I'm going to go ahead and label these. I'm going to label this point number 1. Doesn't matter which point is which, as long as you're consistent once you decide which point is which. So now we have y2 is equal to 9, and y1 is equal to 0, and x2 is equal to 0, and x1 is equal to 3. So we have 9 over negative 3, which is equal to negative 3. So now we have the slope. Now there's 2 ways to do this. So I'm going to show you one method. One method is to use the y-intercept. So we know that m is equal to negative 3, and we know that b is equal to 9. How did I know the y-intercept? Well, because remember, we were told the y-intercept, you see. So if we have the slope in the y-intercept, then obviously we use y is equal to mx plus b. M is negative 3, b is 9. So that's one way to find an equation. But there's another way that's just as easy. And most of the time, I'm not going to show you 2 methods, but these 2 methods are equally easy. So I'm going to do the second method. So we can use point slope. We have a point, and you can choose either one of those points. I'm going to choose 0.30, and we have the slope, which is negative 3. So we can use point slope form. Then we're going to plug in our point and our slope. And there we go. So we can also write point slope form. So if you got either of those answers, and again, you can plug in 0.9 also. If you plugged in 0.9, then that's another way to do it. So if you got that answer, good job. On to part C. Now these problems are going to be a lot easier. So we have the slope. The slope is negative 1/8, and we have y-intercept is a negative 11. So we can use slope-intercept form. We have the slope and the intercept. Of course, we'd use the slope-intercept form. So the slope is negative 1/8, and the y-intercept is negative 11, and you're done. So that easy. So some of these problems are pretty easy. So if you got that answer, good job. Try part D, and when you come back, we'll do it together. All right, we're back. So obviously we have a point and the slope, so we're going to use point slope form. Again, the names of these equations help you to know what form is easiest to use. So we're going to plug in the y value of our point, but it's a double negative, so it's going to turn to positive 1.2. And the slope is negative 4, and the x value is a positive, so it's going to remain negative there. in the equation. And there you go. So if you got that answer, good job. On to number 6. So now we have a system of equations and it tells us to solve. That means find x and y. But again, there are 3 methods to solve a system of equations. There's substitution, elimination, and graphing. You never want to use graphing unless you're forced to use it. So do we use substitution or do we use elimination? Well, we want to ask, is there a variable, a letter by itself on one side of the equation? If there is, then we're going to use substitution because that's the easiest way to do it. Is there a letter by itself on one side of the equation? And there is. It's right here, y. So we're going to take the other equation where a variable is not isolated and we're going to rewrite that equation. The only difference is, instead of y, we're going to write what the top equation tells us that y is equal to. So I took this 3x and I plugged it in there. And the rest of this equation again, it came from there. So I don't know if this highlighting is helping you or hurting you, but at least you can see what's going on. So now we're going to simplify that. 4 times 3x is 12x, and negative 2x plus 12x is 10x. Divide both sides by 10, and we get x is equal to 1/10. So we found x. Now we have to plug back in to find y. So I'm going to use the top equation because that's just going to be the easiest equation to use. So we have y is equal to 3 times x, which is 1/10. So I got that from there. And remember, when you're multiplying a whole number by a fraction, you just write the whole number over 1. And then we're just multiplying 2 fractions. So you multiply straight across. 3 times 1 is 3. And 1 times 10 is 10. So y is equal to 3/10. So if you got those answers, good job. All right, on to number 7. So do we have a letter by itself on one side of the equation? And the answer is no, we don't. So we're going to use elimination. How do we do this? Well, we have 2 coefficients that are the same, and we'd like to add these equations together and eliminate these y's because they're the same coefficient. But if we add these equations together using our elimination method, then we'll get 14x plus 14y is equal to 28. That doesn't do us any good. We didn't eliminate any variables. So what we want to do is we want to change this equation here to negative 7y. Now, one method that I didn't show you that is useful for this particular equation is, instead of adding these equations together, you can actually subtract. 10x minus 4x is 6x, 7y minus 7y is 0, and 5 minus 23 is negative 18. You can actually eliminate that way. That's perfectly fine, but I didn't show you that method, so I'm not going to do that. But you can subtract or add the equations. Just be aware of that. So I'm going to use the methods that we used in my class. So I'm going to multiply the bottom equation. You can multiply the top or the bottom. It doesn't really matter. I'm going to multiply the bottom equation by negative 1. And so then we end up with the same system. The only difference is we have negative 4x minus 7y equals negative 23. So now we can add them together, because when we add these coefficients, they're going to disappear. So we have 6x, 10x plus negative 4x is 6x, 7y plus negative 7y is 0, and 5 plus negative 23 is negative 18. And of course we're left with 6x is equal to negative 18. Divide both sides by x, and we're left, divide both sides by 6, and we're left with x is equal to negative 3. So there you go. So now we're going to plug in x to one of those equations, and we want to try to choose the easiest one, but it seems like they're about equally difficult. So we're going to plug in to the bottom equation 4 times negative 3 plus 7y is equal to 23. We don't have the room to show all these steps. But 4 times negative 3 is negative 12. Add 12 to both sides, and you get 35. 7y equals 35. Divided by 7, you get 5. So y is equal to 5. So if you got those answers, good job. Okay, on to the next problem. Do we use substitution or elimination? Well, you have to ask, is there a letter by itself on one side of the equation? And the answer is no. There's no letter by itself on one side of the equation. So what I'm going to do is I'm going to multiply the top equation by 2, because that's going to turn that 5y into 10y. And then when we add the equations together, the y's are going to disappear. So then we end up with 8x plus 10y is equal to negative 24. And so now we're ready to add, so we draw our line, which signifies that we're adding. 8x plus negative 3x is 5x. 10y plus negative 10y is 0. And negative 24 plus 9, that's going to be negative 15. And divide both sides by 5, and we get x is equal to negative 3. So now we're going to plug in to one of those equations. Doesn't matter which one. I'm going to try the top equation. So we have 4 times negative 3 plus 5y is equal to negative 12. 4 times negative 3 is negative 12. Add 12 to both sides. You get 0. 5y equals 0, so y is equal to 0. And if you want, if you have time, you can test those numbers to see if they work in the equation. It looks like they work. So if you got those answers, good job. On to number 9. So we want to know if we're going to use elimination or substitution. Is there a letter by itself on one side of the equation? And there is. So use substitution. We're going to take the other equation where a variable is not solved for, not isolated, and we're going to rewrite that equation. So try number 9. When you come back, we'll do it together. So I'm going to rewrite this equation, but instead of x, I'm going to write what the top equation tells us that x is equal to. So I plugged in 10 plus 2y here, and the rest of the equation I just copied. Now we're going to simplify that equation, and we're subtracting that yellow part so that positive 10 becomes negative 10, and the positive 2y becomes negative 2y. So then I have 4y minus 2y is 2y, and at that point we have a two-step equation, and you've solved these plenty of times in pre-algebra, at least my pre-algebra course. So we're going to add 10 to both sides, and we get 2y is equal to 2, divide both sides by 2, and we get y equals 1. So y is 1. Now it's easiest to use the top equation to find x, because x is solved for in that equation. So x is equal to 10 plus 2 times 1. And so x is obviously equal to 12. So I got that from here. Now again, it might be useful to check your answers. Let's see, that would be 4 minus 12 is negative 8, so yeah, that works. You want to test it in both equations. Only choosing both equations will prove that it works. So now, see if you can do this problem. Attempt it. Don't just watch me do it. And when you come back, we'll do it together. It says the perimeter of the rectangle below is 50 meters. Find the length of each side of the rectangle. So remember, perimeter is just adding up all the sides. And there's 4 sides. Now be aware that because this is a rectangle, 2w plus 2l That's also a very common formula that's used, but I'm just going to use the topic formula. So now all we do is we just plug in numbers that we know and solve for numbers that we don't know. So do we know the perimeter? Do we know P? And yes, we do. It tells us it's 50 meters in the problem. And S1, that's going to be x squared minus 1. It doesn't matter which is which. There's two of those. There's two x squared minus 1s because whatever this length is going to be the same for a rectangle. We know that just from our experience in the real world. And of course we have two sides that are both 4x plus 5. So now we have an equation that we can solve to find x, and once we find x, then we can plug it in and find the sides. Now it's very important to remember you can add lemons with lemons, okay, and you can add limes with limes, and you can add purple things with purple things, but you cannot add unlike terms. So x squared plus x squared, 1 lemon plus 1 lemon is 2 lemons, you see. And 4 apples plus 4 apples is 8 apples. And then we have -1 plus -1 is -2, plus 10 is 8, so on and so forth. This is just all review stuff. Again, you don't have to use these colors. You're not going to have time to use colors on the test. You need to get the test done as quickly as possible. So now, at this point, we see that we have a very special equation. This is special. And because it's a special equation, it requires special methods to solve it. The problem is, if you don't recognize this as a special equation, you're not going to be able to use your special methods. What kind of equation is this? Well, it's a quadratic equation. How do I know that? Because we have a variable squared, we have a variable that's not squared, and then we have a normal number, two normal numbers. That means it's going to be a quadratic equation. So now we at least recognize it as a quadratic equation, and we can use our special methods. The problem is, it's not enough just to recognize it as a quadratic equation. You also have to put it in standard form so it looks familiar. So I'm going to subtract 50 from both sides so I get 0 on one side of the equation. And we could put everything on the left side, but we want to stick with a positive coefficient on the x squared term if we can. And we get -42. So now it's starting to look familiar. Now it's in standard form. But there's one more thing. I don't want to complicate things here, but there is one more thing that we can do that's going to make this a lot easier. We can divide both sides by 2. How do I know that? Well, because there's a 2, an 8, and a -42. All those numbers can be divided by 2. So before you solve a quadratic equation, if you can make it easier, you want to try to make it easier. So 0 divided by 2, that's just going to be 0. And we end up with, just divide each one of those terms by 2, and we come up with that equation. So now we know to solve a quadratic, at least in this course, where we always solve quadratic equations with factoring. So what two numbers multiply to -21 and add up to 4? What are two numbers that multiply to -21 and add up to 4? If you said, sorry, my computer's going slow. If you said 7 and 3, or -3, you're correct. So all we did was just change the form of this expression here, but now we know that there's some number times another number that equals 0. So that means that in order for that equation to work, we're looking for the x values that will make that equation work. In order for that equation to work, either the blue has to be 0 or the orange has to be 0. That's the only way that the equation can work. So what x value makes the blue 0? -7. We just solved it there. What x value makes the orange 0? Well, that's going to be 3. So I don't know why I rectangle those. We don't want to rectangle those because those are not the answers. Okay. Now, one of those answers is extraneous, because if I plug in -7 here, I get -7 times 4 is -28. -28 plus 5 is -23. There's no way that a side of a rectangle can be negative. So I'm going to go ahead and just cross that equal sign out, because that's not possible. But x does equal 3. So now we have to find the side. So the width is going to be x squared, but in this case we're going to plug in our 3 because we found x. X squared minus 1, and that's going to be 8. So the width is 8. And the length is going to be 4 times x, and again, x is 3. So do the math on that, and you end up with 17. So now we have to write units. Please remember to write your units. We're talking about centimeters here. Actually, no, we're talking about meters. They want the sides. Again, go back and figure out what they're telling you. What are they asking? They're asking for the sides of the rectangle. So we have one side that's 8 meters and another side that's also 8 meters. We have another side that's 17 meters and another side that's 17 meters. So there you go. Okay, so if you got that answer, good job. All right, on to number 11. Says Leonard sold 8 adult tickets and 7 child tickets for a total of $132. Bella sold 5 adult tickets and 4 child tickets for a total of $81. What is the cost per adult ticket and the cost per child ticket? So this is going to be a system of equations problem. And again, the number one thing you want to do is define variables. What are your variables going to be? And the green part is going to tell us. I'm going to let A equal the cost per adult ticket. And C is going to be the cost per child ticket. All right, so that's the most important thing, is to define your variables. If you start talking about A and C or X and Y, and we don't even know what those letters refer to, then it's not going to mean anything. So now we usually try to look for an easy equation. What is an easy equation that we can write immediately? Well, this problem doesn't really have an easy equation. But let's say that you're Leonard, and you just sold 8 adult tickets and you sold 7 child tickets. What are you going to do at that point? Well, what you're going to try to figure out is how much money you made, right? So what you're going to do is you're going to take 8 adult tickets and multiply that by the number of tickets, or by the price per adult ticket. Then you're going to add that. Then you're going to take the number of child tickets that you sold and multiply that by the cost per child ticket, and that's going to give you the total cost. And you're going to do the same thing. Bella's going to do the same thing. And so that's your system of equations. So we have the yellow one and the blue one. Okay, it's good to go back and double check, make sure everything looks right. Everything looks correct. So now, do we have a variable that's by itself on one side of the equation? And the answer is no, we don't. So we're going to have to use elimination for this. So I'm going to rewrite that system. And by the way, what I'm about to do, you don't have to show the actual multiplication. You just have to show the results of the multiplication. But I'm just showing you what is happening here. So I'm going to multiply the top equation by -5 and the bottom equation by +8. One of them has to be negative if we're going to add them together, and they're going to cancel out. So I'm going to go up here because obviously I'm out of room. So -5 times the top equation is going to give us -40 minus 35c negative 40a minus 35c, and then negative 5 times 132, that's going to be negative 660. 8 times 5a, that's positive 40a. 8 times 4c is 32c. And 8 times 81 is going to be 648. Now, that's still a system of equations, so I need to write my brackets. Don't forget to write your brackets. That tells us that those equations are together. Now we're ready to add, so I'm going to signify that by drawing a line. Add negative 40a plus 40a, and you get 0. Negative 35c plus 32c is negative 3c. Negative 660 plus 648, that is negative 12. Divide both sides by negative 3, and we get c is equal to 4. So then, of course, we're going to plug that in to one of the other equations. It doesn't really matter which one. I'm going to choose the blue one. So I'm going to go over here. And we have 5a plus 4 times c equals 81. And if you solve that, we end up with a is equal to 81, or 4 times 4 is 16, and 81 minus 16 is 65, so we have 5a is equal to 65. Divide both sides by 5, and we get 13. So a is equal to 13. So we don't have a lot of room here, so I'm just going to go ahead and write the units. So that's $4 per child ticket, and $13 per adult ticket. And we want to rectangle that. Now, you must write your units. If you forget to write your units, then you're going to lose points. In these word problems where we have systems of equations, actually in pretty much any word problem, you usually have units. So if you got those answers, good job. Okay, on to number 12. For problem numbers 12 through 15 below, always label the axes of your graphs and the intervals on each axis. Write all coordinates you use to make your graphs. So graph the following equations. So you might say, well, how come you're not giving us graphing paper or something to help us with this? And the reason is you need to know how to draw your own axes sometimes. And so we're getting practice with that. So I'm going to make this 6. That would be 6. And we don't have time to, show all this, but it's going to be x is equal to negative 6. So that's going to be somewhere over here. You just have to give some indication of what your intervals are. You don't have to draw every single interval, and the graph doesn't have to be perfect. A lot of students, they will sit here and spend a lot of time just trying to draw a perfect graph. That's a waste of time. Don't do that. Just make sure you have your axes labeled and your intervals written so people know, roughly what the spacing is. All right, so that's x equals negative 6 is a vertical line. We learned that in a previous problem. Now, y is equal to negative 2. So that's going to be down here. It's going to be a horizontal line. And that's it. That's pretty much all you need. So if you got those answers, good job. All right, on to number 13. Graph the following equation by plotting 2 points and connecting the dots. So that's method number 1. Remember, we learned 4 methods for graphing an equation, a linear equation. So point 1, we're going to let y equal, let's say we'll let y equal 1. Actually, let's just try 0. 0 is usually a good value to choose. Makes the calculations easier, usually. Why did I choose y instead of x? Well, because x is solved for, so it's going to be a lot easier to do the math. And we see that x is equal to 2. So I have a point, 2, 0. Don't confuse, don't switch around the x and the y value. Some students will write, they'll write 0, 2. That's going to give you the wrong coordinates. So now I'm going to let y equal 2. So now we have x is equal to 2 minus 2, and we have x is equal to 0. So it just turns out that we got the x-intercepts on this problem. In fact, I'm going to choose something else because I don't want the x-intercepts. We're going to do that in another problem. I'm just going to choose 1, so we have x is equal to 2 minus 1. X is equal to 1, so our coordinates are 1, 1. So now we can make a table that's going to help us kind of organize this. Whenever we're going to use method 1, basically what that means is we want to use a table. And so now we're ready to draw our graph. Again, the graph doesn't have to be perfect. So we have the point 2, 0, which is there, and we have the point 1, 1, which is there. And we connect the dots and we're done. So it's that easy. I don't know what I was thinking there. It should be 1, 1. I'm sorry. So that should be there. Connect the dots. And make sure that you fill your window. It's got to go all the way up there. So we have 1, 1 and 2, 0. So there you go. If you got that graph, good job. That was using method number 1, which is basically just using 2 random points. You see. So on to part B. Now we're going to use method number 2. Method number 2 is using 2 points also. It's pretty much the same type of method. The only difference is we're not using random points. We're using special points, the x and the y intercepts. So again, try this if you think you can do it. The x-intercept always has a y value of 0. So that's how I know to find the x-intercept. Let y equal 0. So I have 6 is equal to 2x plus 3 times 0. And if I solve that, I get x is equal to 3. So our coordinate is now 3, 0. So I didn't find just any point. Okay. I found the x-intercept. It's basically the same type of method, except we're finding not just random points, we're finding intercepts. So now to find the y-intercept, I let x equal 0. So now I plug in 0 for x into that equation up there. And if I solve, I end up with y is equal to 2. So the coordinate is 0, 2. So the x-intercept is 3, 0. The y-intercept is 0, 2. And again, a table is helpful when you're using 2 points like this to graph. So we have 3, 0. You don't have to write a table if you don't want to. 3, 0 and 0, 2. And so we're going to graph. And remember, you have to label, you have to put some intervals there. So now 3, 0, that's going to be here, and 0, 2 is here, and we connect the dots, and we're done. So there we go. This line looks similar to the one we graphed previously. And so we have 0, 2 and 3, 0. There you go. So if you got that answer, good job. That was method 2. Now we go on to method 3. Again, we learned 3 methods for graphing, and it's a lot of it's based on what you're starting with. So we now have slope-intercept form. y is equal to mx plus b. I know it's slope-intercept form because y is isolated, and that's why it's telling us to use method 3, the slope-intercept form method. So the slope is 4, and the y-intercept is 0 because there's nothing here. So b is going to be 0. So m is 4, the slope is 4, b is 0. So now I'm going to graph this. So whenever you use method 3, the slope-intercept form, you always start with your y-intercept, which is going to be here. And I'm going to use red this time. You start here, and then you go up 4, 1, 2, 3, 4, and over 1. Because remember, this slope can be written as 4 over 1. The rise is 4, and the run is 1. So I'm going to make this, I should back that off a little bit. Roughly there. And we need 1 and 1, 2, 3, 4. So then we connect the dots and we're done. So again, it's a good idea to label your points on the graph, 0, 0, and we have 1, 4. So if you got that green line there, good job. Now we're going to use slope-intercept form again. We have mx plus b is equal to y. And so m is equal to -2/5 and b is equal to -3. We don't have time to color all this stuff because it's just going to take too long. I'm trying to make this video not go too long here. And so now we start with the y-intercept, which is -3. B is -3. Now I forgot to mention that, remember, when you're using this slope-intercept method of graphing a linear equation, you plot the y-intercept, but then you keep your pen on that y-intercept. Okay, you keep it there. And then you go down from there 2 and then over 5 because the slope is -2 over 5. The problem is we can't do that because we're off the graph. So how do we deal with this situation? Well, instead of going down and over 5, what we can do is we can go up 2 and to the left 5. You see, that's going to be -3 and 1, 2, 3, 4, 5. That's about -5. Again, your graph doesn't have to be perfect. And we connect the dots and we're done. Try not to draw your numbers right on the line though. So we have 0, -3 is the y-intercept, and the other point is -5. So if you got that answer, good job. Again, make sure to label, put some units on your intervals on the graph and label the x and y axes. On to number 15, we're going to use method 3 again for this problem. So we see that we have slope-intercept form, but I'm going to rewrite that expression so the 1/2 is in front of the x. That can be kind of confusing. So we see that m is equal to 1/2 and b is equal to 2. And maybe I should color those just so you can see what's happening there. So now we're ready to graph. And you start with the y-intercept, which is 2. And you graph that. Then you keep your pen on the y-intercept and you use the purple slope. You go up 1. So up 1 and over 2. And that gives you your second point. And obviously we're going to have to move that 3 to the other side. Then you connect the dots and you're done. So the points are 0, 2 and 2, 3. So if you got that answer, good job. Okay, so now we're going to use method 4. And we use method 4 when we're given the point-slope form of the equation of a line. So that's y minus yp is equal to m times x minus xp. And obviously if we're given the slope-intercept form, then we're going to use, or excuse me, if we're given the point-slope form, then we're going to use a point given to us in the equation and the slope. So our point that we're given is -1, +2, and the slope is -3. Now again, you're going to say, wait a second, you reverse the signs. That's not -1, that's +1. And that's not +2, that's -2. Well, again, the signs reverse when you use the point-slope form. You know, if you do a little practice, then you're going to remember that. But if you don't study for the test, then, you know, it's a 100% guarantee you're going to forget that. So now, let's just plot those points. I'm going to do some intervals here. -1, 2. That's going to be here. So that's our point. That's how we use method number 4. We plot our point first, and then we're going to use the slope. Now this says -3, but that means -3 over 1. It's the same thing as -3 over 1. So, and it's very important to remember, this is negative. It's a -3. So instead of going up, you're going to go down 1, 2, 3, and over 1. And that gives us our next point. So then we just connect the dots, and we're done. So as you can see, method 4, if you're given the point-slope form of an equation, method 4 is really easy. So we have -1, 2 is our point. And this other point down here is 0, -1. So if you got that answer, good job. Again, remember to label your axes, draw your intervals, so on and so forth. Okay, on to number 16. Now again, you want to attempt these problems. Don't just watch me do them. If you think you know how to do the problem, attempt it. Don't watch me do it. Okay, so it says use the slope equation to find the slope of the line containing the 2 points below. So remember, the slope equation is m is equal to y2 minus y1 over x2 minus x1. You must write m equals. You can't just write this expression. That doesn't mean anything. You have to tell us what we're trying to find. And we have to figure out what point is going to be point 1 and what point is going to be point 2. Doesn't really matter which is which as long as you're consistent. So then we're going to plug in our numbers. y2 is -2, y1 is 7, x2 is 3, and x1 is -4. Now we have a double negative. You see that double negative? Be very careful. I'm telling you, be careful there. A lot of students will have trouble with that. And so we can simplify to -9 over 3 plus 4 is 7. That becomes 3 plus 4. So let's just double check that. We have 9 over -7, so yeah, that works. -9 over 7. So now we have the slope. That's part A, and we should label this part A so we know what part we're on. And then it says write the point slope form of the equation. Notice it says a point slope form because there's multiple point slope forms depending on what point you use. So we want to use y minus yp is equal to m times x minus xp, and you don't have to write this equation. I'm just writing the equation to let you know what form I'm using. So I'm going to plug in 7 because I'm using this point over here, -4, 7. So I'm going to plug in 7 for the y value. The slope we found is -9/7, and then the x value is for that point is 4, so it changes sign to +4 because it's a negative. We're subtracting -4 becomes +4. So that is the point slope form. You can see that's pretty easy. So that's part B. Then for part C, it says convert that form from convert the equation from point slope form to slope intercept form. So now I'm going to take that equation and I'm going to use distribution because I got to get rid of those parentheses. So we have -9/7 times x and -9/7 times 4. That's going to be -36/7. And we're almost done at that point. In fact, I'm going to show that I'm starting with that equation above. You don't have to show every single one of these steps, but you do have to show some of this work on the test. So now, if I add 7 to both sides, we're going to have to do some arithmetic here. 7 becomes 49/7. And so if I add 49/7 to both sides, then I get 13/7. So plus 13/7. And that is the answer to part C. We converted from point slope form to slope intercept form. All right, now on to part D, find the y-intercept of the line. Finding the y-intercept is going to be very easy because we now have slope-intercept form. So we can see the y-intercept just by looking at it. We see it's 13/7. So we can just say B is equal to 13/7. And I'm going to color that so we know where we got that. That came from there. So if you got those answers, good job. Again, it may have been a while since we did these problems, a couple days, couple weeks, whatever. Whoops, I forgot to rectangle -9/7. So make sure you have rectangles for all the parts. Remember, your answers have to be rectangled. I'm probably going to give you more room for these problems on the actual test. So now we're going to go to the sourdough problem. Sourdough bread costs $3.18 per loaf, and rye bread costs $2.29 per loaf. Ellis spent $68.18 on these two items. He bought 10 times more sourdough loaves than rye loaves. How many loaves of each type of bread did he buy? So maybe we should break this up into parts. So we're definitely going to make an equation out of that. First thing we need to figure out is the purple part. What are our variables going to represent? So I'm going to let S equal, the purple says how many loaves of each type of bread. So S is going to be the number of loaves of sourdough. And you can abbreviate it. You don't have to write sourdough the whole thing. And R obviously is going to be the number of loaves of rye bread. So that's the purple part. I know to define my variables that way because that's what we're looking for. That's what the problem is asking for. So now, do we have an easy equation that we can work with here? It doesn't seem like we have an equation that's that easy, but the blue equation, I think we're going to start with that. That's the easier one. It says he bought 10 times more sourdough loaves than rye bread. So sourdough, the number of sourdough, this can be kind of confusing, but what it's telling us is that the number of sourdough loaves is 10 times the number of rye loaves. So that's what that blue statement tells us. So that's one of our equations. The other equation is going to be this complicated green stuff here. all this green information is going to give us a kind of a more complicated equation. Sourdough bread costs $3.18 per loaf. Rye bread costs $2.29 per loaf. He spent $68. So what that means is, if you take the cost per sourdough loaf, which is $3.18, and you multiply that by the number of sourdough loaves, that's going to give you all the money he spent on sourdough loaves. If you then take the cost per rye bread loaf and multiply that by the number of rye bread loaves he bought, that's going to give you the cost, the amount of money he spent for rye bread. Add all that up, and you're going to get the total amount of money he spent on all this bread, and that's $68.18. So that comes from the green part there. But I'm going to get rid of this highlighting because we're going to use substitution. Now, how do I know we're going to use substitution? Again, we can use elimination or substitution, and we never use graphing unless we're forced to. How do I know to use substitution? Well, because one of the variables is by itself on one side of the equation. That means substitution is probably going to be the easiest method to use. So what that means is we're going to take the equation where one variable is not solved for, and we're going to rewrite that equation. We're going to write the same exact equation, no difference whatsoever, except instead of s, we're going to write what the top equation tells us s is equal to. And so at this point, well, 3.18 times 10, you just move the decimal one place over. I don't know if we have time to show all this work. 31.8 r plus 2.29 r. You can do that on your calculator if you want. A calculator is allowed on this test. 31.8 plus 2.29 is 34.09. And I'm going to go ahead and take that up here. So 34.09 r is equal to 68.18, and then divide 68.18 by 34.09, and we get r is equal to 2. So that's going to be the answer. We have r is equal to 2 rye loaves. And then in order to figure out the number of sourdough loaves, we just use this equation. That's the easiest one to use. So s is equal to 10 times 2. And we got our 2 from there. So then we have s is equal to 20 sour loaves, and you can abbreviate because we don't want to take up a lot of time having to write the units. So 20 sour loaves and 2 rye loaves. So if you got those answers, good job. On to number 18, it says use the slope-intercept equation to find the slope-intercept form of the line with the given characteristics. Now, a lot of students get confused with this. You know, we're given the y-intercept and we're given a point. So we could say, well, the y-intercept is 0, 2, and we have... so what this means, when it says in the red, use the slope-intercept equation, what that means is you're going to write the slope-intercept equation, because there's multiple ways to do this. So we're going to plug in the y value of our point, the slope we don't know, the x value of our point, and b, we're given b is 2. And maybe I should write that. That was one of the pieces of information they gave us. B is equal to 2, you see. So now we have -7 is equal to -m plus 2. And if we solve that equation, we end up with m is equal to 9. That's just a two-step equation. So now we have the slope. And it says use the slope-intercept form to find the slope-intercept form. So we found the slope, and we have the y-intercept. So now I'm going to go up here. So slope is 9, and y-intercept is 2. And so now we can use y is equal to mx plus b again. So b is, or m is 9, and b is 2, and you're done. So you see how we used the slope-intercept form over here. I know it's kind of complicated, but we use the slope-intercept form to find the slope-intercept. To be honest with you, that's the method that a lot of that most engineers and scientists actually use in the real world. It's just the easiest way to do it. So on to part B. Again, we have to use the slope-intercept form. So we're given the slope is 4, and we're given a point, -5, -3. I guess I don't have to write the point again. And we're going to use the slope-intercept form, which is y equals mx plus b. So we plug in our y value, and I want to show where those values came from. So I'm going to plug in -7, or highlight -7, -1, and b is 2. So I'm going to show where that stuff came from. Again, you don't have to use colors when you do your test. So m, we know, is 4. The x value of the point is -5. And we don't know b. So I'm not going to use colors at this point. We don't have enough time for that. So now, solving that equation, we see that b is then equal to 4 times -5 is -20. Add 20 to both sides, and we get 17. So b is equal to 17. So at this point, it's very important to understand that we have the slope and the y-intercept. The slope is 4. The y-intercept is 17. So now we can write our slope-intercept form. We plug in our slope, and we plug in our y-intercept, and that's it. So we use the slope-intercept form to find the slope-intercept form of the equation. All right, so on to number 19. For each problem below, write an equation of the line with the given characteristics. So we're told that our line is parallel to the line with this equation, and our line contains the point 5,2. This can be kind of confusing to students. So if our line is parallel to the line with this equation, that means that our line has the same slope as the equation with this, or the line with this equation. So this is in y equals mx plus b form. So the slope of this line here, the slope of the line that is parallel, that is equal to -2. How do I know that? Well, because y is equal to mx plus b. So m is equal to -2. The slope of that line is -2. But because the line is parallel to our line is also -2. Or the slope of our line is also -2. So now we have the slope of our line, and we have a point on the line. So we can just use point-slope form. Y minus yp, sorry I didn't give a lot of room here. Y minus yp equals m times x minus xp. So now we just plug in our point, and the slope we found is -2. And we're done. So it's that easy. You really don't have to show a lot of work on that particular problem. You don't have to show this part, and you know it's good to show this part though, that you found the slope. So now we want to find the equation of a line that's parallel to this line and containing that point -6,3. Now, again, because our line is parallel to this line, it has the same slope. Well, this equation here, what is the slope? Well, we can see the slope just by looking at it because it's in point-slope form. I don't know why I did that. I was just trying to write the point-slope form. See, that's point-slope form. So 2/3 is the slope. And I'm writing this little parallel symbol in case I didn't mention. That's a parallel symbol. So the slope of the line that's parallel to our line is also 2/3. They have the same slope. And of course we have the point -6, 3 on our line. So now we can write point slope form because we have the slope and a point. So y minus yp equals m times x minus xp. Plug in our point. Y is 3, slope is 2/3, and the x value is -6, so that changes to +6. Again, the signs reverse. Just memorize that the signs reverse and don't complain about it. A lot of students complain. They say, I don't understand why the signs reverse. Well, to be honest with you, good students don't complain about why they don't understand why the signs can reverse. They just memorize it and they go on to the next thing. If you want to know why the signs reverse, you can learn that later on. Again, if you're going to learn how to drive a car, you don't take apart the car and learn how the car works first. First, you learn how to use the car. Then, way down along the line, when you decide to become an engineer, then you can take the car apart. That's how the math works here. So, on to part C. We're looking for the equation of a line that's perpendicular to the line with this equation and containing the point 1, -1. So now this is in slope-intercept form. M times x minus xp is equal to y minus yp. It's just that the equation's reversed. So now we're told that our line is perpendicular to that line. So I'm going to find the slope of the line is perpendicular. That symbol means perpendicular. And that's going to be, see, this slope here is 76, so I'm going to flip it around and change the sign. That's how you find the slope of a line that's perpendicular to another line. It's 76 over 1, so I flipped it. Again, this can be written as 76 over 1, so I flipped it. And it became a negative. You want to change the sign and flip it around. So now we have a point and we have the slope. So obviously we're going to use point slope form, just like we did in the previous problems. So y minus yp is equal to m times x minus xp, same equation I wrote in red. Plug in the y value, which is -1, so it becomes positive. The slope is -1 over 76. Then we have x minus 1, and that is your equation. Again, I'm writing a lot more than you really have to write on the test. I'd prefer if you showed this part here, but you don't have to really write any of the other work. You can just write that part and then write your answer. I'm just doing this work to show you what's going on. Now we're looking for a line that is perpendicular to the line with this equation and containing the point 3, 1. So if we can find the slope of this line and then flip it around and change the sign as we did up here, then we can find the slope. The problem is this is in standard form. That doesn't give us any information about the slope. So what we have to do is we have to convert that equation to slope-intercept form so we can see the slope. So I'm going to start with that equation, and then I'm going to put the 8x on the other side, and I need some more room here. So then all we have to do is divide by 5, and we see we end up with y is equal to -8/5 x minus 1. So now it's in slope-intercept form, so now we can see the slope. Now, our line is perpendicular to the line with this equation here, which is the same as that equation, just in a different form. So now we see that the slope of our line, which is perpendicular, so I write a perpendicular symbol, we flip it and change the sign, so it would be 5/8, positive 5/8, not negative 5/8. So now we can write the point slope form. Again, you don't have to write this equation every time. I'm just using it to show you what's going on. So we plug in our y value, plug in our slope, which is positive 5/8. And there we go. It doesn't say that you have to write any particular form, so we just want to use the easiest form. Now, you see what I did up here? That's a big no-no. That negative sign is too close to the fraction. So I'm going to take that out like that. Or to be really safe, I can just put it up next to the 1 maybe. So just double checking here, everything looks right. So there you go. Okay, on to number 20. I think I'm going to find some more room here. Okay, Daniel has dimes and quarters in his pocket. The value of these coins is $4.85. If he has a total of 26 coins, how many of each type of coin does he have? So, like I said, the most important thing is to define variables. So obviously, this last part here, how many of each type of coin does he have, that tells us what our variables are going to be, or they're going to be defined as. So D is going to be equal to the number of dimes, and Q is going to be equal to the number of quarters. So again, that last sentence tells us what our variables are going to be. Now, there's a really easy equation that we can start out with. That's going to be the blue equation, or the blue clause. So that blue clause tells us the number of dimes plus the number of quarters is equal to 26. So that was really easy. All right. The next equation is not going to be so easy. You have to think about this a little bit. Now, we know that the total value is $4.85, so think about it. If you're going to add up the total value of the coins in your pocket, how would you do that? Well, you take the value of each coin. The value of a dime is 0.01 dollars. I know it's kind of hard to think of it as a decimal, but that's what 10 cents is. It's 1/10 of a dollar. And you multiply that by how many dimes you have. Then you take the value of a quarter, which is 25 cents, and you multiply that by how many quarters you have. Then that should equal the value of all the coins. So, I know that's coming up with that equation is easier said than done, but there's two ways that you can remember to make that equation. One way is to just memorize how to do it, which is what most students do. And the other way is to actually think about it conceptually. A lot of students will say, well, I'm having trouble understanding it conceptually, so I'm not going to do the problem. Nope, you're going to do the problem anyway. You're going to memorize how to do it, even if you have trouble with it conceptually. Again, you may not conceptually understand how a car works, but that doesn't mean you can't learn how to drive the car, does it? So, now we're going to solve the system. So do we use substitution or elimination? Well, we don't have any letters that are solved for, isolated by themselves on one side of the equation, so we're going to use substitution. So I'm going to multiply the top equation by negative 0.1. And notice that using dots here is going to get kind of confusing, but that's just going to be the best notation to use in this particular example. So I'm just going to use a dot for multiplication there. Now I could multiply both sides of that equation by negative 0.25. It doesn't really matter. You're going to get the same answer. So now we end up with a new system, which is negative 0.1d minus 0.1q, and then 0.1 times 26 would just be 2.6, and of course it becomes a negative. And why did I multiply by a negative? Well, because we want to add them together and have them cancel out. Now you could use subtraction, then you wouldn't have to multiply by a negative, but I didn't show you that method. It's easy, you just subtract instead of adding together. Then you wouldn't have to multiply by a negative. But I didn't go over that, so I'm not gonna do it that way. So now we're ready to add these together because we have these coefficients that are the same. So we're going to add them together. These cancel out. You end up with 0. Negative 0.1q plus 0.25q is going to be 0.15q. And negative 2.6 plus 4.8, you can use your calculator for that. Don't be afraid to use your calculator. Negative 2.6 plus 4.85, that's equal to 2.25. Then we're going to divide both sides of the equation by 0.15, and we end up with 15. So 15 quarters. That's one of the answers. And now we're going to figure out how many dimes, obviously, so we can just use that blue equation. And so the number of dimes plus 15 quarters is equal to 26. And just to be clear where I got that number, obviously you don't really need me to do that, but I'm just making everything as clear as possible. And we have 11 dimes. And please write the units for these problems. All right, so if you got that one right, good job. Now we're going on to this alcohol problem. Chris wants to make 3.6 gallons of fuel that is 20% alcohol. He has fuel that is 30% alcohol and fuel that is 14% alcohol. How many gallons of each mixture should he combine? So again, we know what to define our variables as. That's the first thing that we need to do, is to define the variables. So we can't really use letters for x and y are going to be best. So x is going to be gallons of 30%, and y is going to be gallons of 14%. So now we're ready to make our two equations, and the first equation is going to be really easy. Now this problem is very intimidating to students. This is maybe one of the most intimidating problems, other than the last one we're going to do today. But the first equation is really easy. If we add these two ingredients, we should have 3.6 gallons. You know, it says we're going to make 3.6 gallons. So you add your 14% and your 30%, and you should get 3.6 gallons. So that's easy. Now, here comes the hard part. The second equation is not just going to be the gallons of the whole thing, the alcohol and whatever other ingredient is in there. The second part is just going to be how much alcohol. So we're going to find 20% of X to figure out how much alcohol is actually in X. When you want to find a percent of a number, you take the percent, change it to a decimal, and then multiply that by that number. So same thing for the 14%. We take 0.14, multiply it by the number of gallons of the fuel, and that tells us how much alcohol. So this is how much alcohol in the, actually that should be, I'm sorry, that should be 0.3. Sorry about that. So we figure out this is how much alcohol is in the 30% fuel, and this is how much alcohol is in the 14% fuel. So that should give us the total amount of alcohol in 3.6 gallons. But the total amount of alcohol in 3.6 gallons, we're going to figure that out by taking 20%, changing it to a decimal, and multiplying by 3.6. That's just how you figure out this is how much alcohol is total. Find 20% of 3.6, and that's how much alcohol should be in there total. Now, I know what you're thinking. You're thinking, this is too much. I can't take it. This is too difficult. But again, just memorize how to do these types of problems. I'm not going to trick you and give you, a lot of different variations of these problems, but you do need to know how to do some of these problems. If you don't understand every part of it, then just memorize how to do it, and then you can learn the concepts later on. Not understanding the concepts is not an excuse for not learning how to do the problem. So 0.2 times 3.6 is 0.72. I just simplified that. And now there's no letter that's solved for, so we're just going to use elimination. So I'm going to multiply both sides of this equation by negative 0.3. There's multiple ways to do it. I'm just going to eliminate x. And we can use the calculator. 3.6 times negative 0.3 is negative 1.08. And now I'm going to add these together, and I get 0 plus 0.16y is equal to, and again, you can use your calculator to find these numbers. We get negative 0.36. Divide both sides by 0.16, and we get y is equal to 2.25. And I'm going to say gallons of 14%. Gallons is usually abbreviated with the GAL. So that is one solution. And we want to use the easiest equation possible. So the easiest equation possible is this one, the top one. So we have x plus 2.25 is equal to 3.6. Again, we're trying to now find the number of gallons of 30%. Subtract, and we end up with, again, you can use a calculator for this if you need to. 3.6 minus 2.25 is 1.35 gallons of 30%. And that's your other answer. So if you got those answers, good job. Okay, so now we're going to solve this system of equations using the graphing method. Remember, you'd only use the graphing method if your teacher forces you to. Otherwise, it's just not the best method, but we need to understand how it works, so we're going to do one problem that requires the graphing method. Now you see we have two equations in standard form, and in that form, we can't see the slope, we can't see the y-intercept, we can't see a point, we can't see anything. We're going to, the best method to use is probably the method number 2. So this is line number 1. I'm going to graph line number 1 here, and we're going to use I guess I'll call that point A. We'll use x and y intercepts. So I'm going to let x be 0 because that's what you do when you find the y-intercept. So I'm going to let x equal 0 in the equation, and then solve for y, and we get negative 1/2. So the point that we found is 0, negative 1/2. Now I have to find 2 points to graph a line, right? So we're just graphing our first line here. So now I'm going to let y equal 0. Again, this is just the easiest way to do it, method number 2, finding x and y intercepts. So I'm going to let y equal 0 in the equation, and when I solve, I get 4/9. So the point that we found is 4/9, 0. So I'm going to call that point B. So now we can graph these points. 0, negative 1/2, that's going to be about there. And 4/9, 0 is going to be about there. You can see why this is not easy to graph. I'm going to go ahead and connect the dots. We can kind of get an idea of what the line looks like. This is not easy to graph at all. This is one of the reasons, the purpose of this problem is not only to teach you the concepts of the graphing method, but also to show you that it's not really practical in many cases. In this situation, it's not going to be practical at all. In fact, you see here in the red, it says you might not be able to solve the system using this method. So move on to part B to help you label the coordinates of intersection in part A. So what you're doing now. Okay, so now we're going to graph line number 2. And So I'm going to use the same method because we have standard form in the purple equation too. So I have negative 6 times, I'm going to let x equal 0. We have negative 6 times 0 plus 7y is equal to negative 2. Solve that equation and we get y is equal to negative 2/7. So we found our first point for line 2. It's 0, negative 2/7. And so now let's find point, we'll call it point D. And we're going to let y equal 0. So letting y equal 0 in that equation, negative 6x plus 7 times 0 equals negative 2. And so we end up with x is equal to 1/3. So our point is 1/3, 0. All right, so I'm going to get rid of this graph here because that's going to be too difficult to see. I'm going to bring this graph down, change the scale a little bit. So we had 0, negative 1/2, which was here, and we had 4/9, 0, which is about here. And we connected the dots for that line. Okay. So now we need coordinates and a scale. So I wrote that pink scale there in my red coordinates. So now I'm going to use purple dots for these other points. 0, negative 2/7. 0, negative 2/7 would be about there. And 1/3, 0 would be about there, roughly, pretty close to that other point. So 1/3, 0. Okay, so now we have to connect these dots. So now let's go ahead and connect these. I'm going to use orange. And you can see it's kind of hard. You want to make this obviously as straight as possible. Sometimes it's difficult. What helps artists is you put your pen back and forth along here like this, and then eventually you kind of get the idea of where to place the line. It should be somewhere like that. It's not perfectly straight, but it tells us that we're supposed to the intersection is supposed to be somewhere around there, and I think this point is supposed to be a little higher here, but whatever. So at that point, I want to make that blue. Blue is probably not the best color. I want to make it light green. That point is what we're looking for. That's our answer. Problem is, we don't know what that point is. I mean, what is it? We can guess, but we don't really know exactly what it is. So you see how this graphing method, it just doesn't really work that well in some cases. And again, if our graph is just a little bit off, which you can see that it pretty much is a little off with these coordinates, they're not placed in the exact same right place. The graphing method just doesn't work very well. So that's one of the purposes of doing this problem. So let's go on to part B. It says here, you might not be able to solve the system using this method, so move on to part B to help you label the coordinates of intersection in part A. So we're going to actually solve this system algebraically now. These equations are both in standard form, and there's no letter that's by itself on one side of the equation, so the easiest method is going to be elimination. So I'm going to multiply this equation by 2, and I'm going to multiply this equation by 3. And I get 18x minus 16y is equal to 8, and negative 18x plus 21y is equal to negative 6. Now I can add those together, and I get 5y is equal to 2, and y is equal to 2/5. So now I can plug in y to one of those equations. I'll plug it into the bottom equation, I guess. So we have negative 6x plus 7 times 2/5 is equal to negative 2. And then we have negative 6x plus 14/5 is equal to negative 2. And again, there's a lot of arithmetic going on here, but this is all stuff that's you should know. We can change this to negative 10/5 and then subtract 14/5 from both sides. We got negative 10/5 minus 14/5 is negative 24/5. And then we divide both sides by negative 6. And when you divide, you can just, negative 24/5 divided by negative 6. You flip that around. So it becomes negative 24/5 times negative 1/6, and so on and so forth. And you don't have to show all this arithmetic, but I'm just reminding you how to do this. So you end up with 4/5. All right. So those are the two solutions. So now that we know what the answers are, we solved algebraically, but that's going to help us actually find the coordinates that we need for part A of this problem. So the coordinates are 4/5 and 2/5. And you can see that our graph wasn't really that accurate. I mean, 4/5 is kind of there. That's going to be somewhere around here. But 2/5, that should be, I guess it's kind of accurate. 2/5 should be somewhere around here. So it's not, the graphing method is really not a very accurate way to solve these. But anyway, let's go on to the next problems. Jeff wants to make 20 ounces of a mixture of jelly beans and gumdrops that costs $3 per ounce. He has a mixture of jelly beans and gumdrops that costs $1 per ounce, and a mixture of jelly beans and gumdrops that costs $7 per ounce. How many ounces of each mixture should he combine? So, we have to start by defining our variables. And it looks like we're going to have to use x and y. So x is going to be the number of ounces of $1 per ounce mixture, and y is going to be the number of ounces. Maybe I'll just spell it out so you know exactly what's going on so it doesn't get confusing. Number of ounces. So that tells us what our variables are going to be. We have 20 ounces. We're going to make 20 ounces. So the first equation is going to be really easy. X plus y is equal to 20 ounces. So that's really easy. But then the second equation is going to be the hard one. The second equation is going to be all based on money. So he has a mixture of jelly beans and gumdrops that costs $1 per ounce. So you're going to take the number of ounces of $1 per ounce mixture, and you're going to multiply it by 1 because it costs $1. So how much of that stuff do you have? And then multiply it by 1 because each ounce costs $1. Then you're going to take the number of ounces of $7 per ounce mixture and multiply it by how much that costs, which is $7 per ounce. So this is the cost of all the $1 per ounce mixture, and this is the cost of all the $7 per ounce mixture. And you're going to then add up how much money it's going to cost total, which is going to be the total number of ounces times how much it's going to cost per ounce, and that comes from here. So that's the hard equation. That's the one where students have a lot of trouble. So now we're going to rewrite the equation and simplify. So we have x plus 7y is equal to 60. And now the easiest way to solve this is a way that I didn't really show you. That is, you're just going to subtract the two equations because we already have coefficients here that are the same. So what you could do is you could just subtract the equations. And then you get negative 6y equals negative 40, and you solve it from there. But I didn't show you how to do it that way. So I'm just going to do it the way we normally do it. I want to multiply the top equation by 1 and just rewrite the bottom equation. And then I'm going to get the same coefficient, except it's going to be the opposite sign on the top equation. So now we're ready to add. We add them together and we get negative 6y is equal to 40. Actually, I'm sorry, that should be positive 6y. So then we divide and we get y is equal to, and you can use a calculator if you want. You don't really need a calculator. I mean, 6 goes into 40 6 times, and the remainder is 4. So we have 4 and 4 6, but if you reduce that, it ends up being 2/3. So OZ, ounces of Y is ounces of $7 per ounce, and we can just let that be the answer. But then, of course, as you know, we have to find the number of ounces of the $1 per ounce mixture. So we're just going to take that yellow equation, bring it down here, and plug in y. So we have x plus y is equal to 20. We have 20 total ounces. And just to be clear, I got that from here. And you should be able to just do this in your head. So subtract 6 2/3 from 20, and you get 13 1/3 ounces of $1 per ounce mixture. And so there you go. So if you got that answer, good job. Okay, we have 2 more problems. Bill is 6 feet tall. He slings a rock up into the air. So 6 feet tall guy slings a rock up into the air. The height of the rock in feet, t seconds after release, can be modeled by the following equation. So here's the height of the rock, t seconds after he slings it. Find the height of the rock 2 seconds after release. So that's really easy. All you have to do is just plug in 2 seconds into t and do the math. So we have negative 16 times 4 plus 95 times 2. That would be 190 plus 6. And then negative 16 times 4 is negative 64. 196. And again, you're allowed to use a calculator on this test. So 196 minus 64, you can do that on your calculator if you want to. That would be 132, and you must put feet. If you don't put feet, then you're going to lose points on that. So if you got that answer, good job. Now, how many seconds after release will it take for the rock to reach a height of 85 feet? So now we're looking for the seconds. So I'm going to write, I'm just going to write 85, plug in 85 for h. And so I wrote the same equation. I just plugged in 85 for h. And it's very important to understand that this is a quadratic equation. A lot of students would get stuck here. So we plugged in 85 for h, and we're going to solve for t to figure out how many seconds after release it'll take for the rock to reach a height of 85 feet. But this is quadratic, so you have to use special methods to solve this special equation. But if you don't recognize it as a quadratic, then obviously you're not going to be able to solve it. So we have a t squared, we have a t, and we have other numbers with no t's. That's why I know it's a quadratic. Again, many students will get to this point and they'll just get stuck. Now, it's not enough just to recognize it as a quadratic. You also have to put it in standard form. We can't solve it unless it's in standard form. We want a positive coefficient here, so I'm going to put the 16t squared on the other side. And so I'm going to put the 95t on the other side also. And I'm going to subtract 6 from both sides, and I get 79. So now it's in standard form, and we have the coefficient of the t squared term positive, which we prefer. And so now we're going to factor, but this coefficient here makes things, complicated. If that 16 were not there, we could just ask what two numbers multiply to 79 and add up to negative 95. But because of 16, we can't do that. So we have to first ask what two numbers multiply to 16. There's 3 options: 1 times 16, 2 times 8, or 4 times 4. So I'm going to try 4 times 4. I don't really know what it's going to be. What two numbers multiply to 79? Well, 79, that's not an easy number. I think that might be prime. So I think the only answer that's going to could possibly work is 79 and 1. And they have to multiply to a positive and add up to a negative. So they're both going to be negative. Now, I can tell just by using FOIL already this is not going to work. You know, if you do O and I of FOIL, then it's not going to add up to 95. So I'm going to change the 4s to, I think I'm going to change this to 16 and 1. So 16 times 1, don't you agree that 16 times 1 is 16? So that might work. Sorry, I don't know what my computer's doing there. So 16 times 1. And so now if we FOIL this out, we have F of FOIL, O of FOIL, I of FOIL, and L of FOIL. And you can see if we add these up, you can use a calculator if you want, but we're going to get 95, negative 95t. So that's what we're looking for, negative 95t. So what that tells us is that there's 2 solutions. If 16t minus 79 equals 0, then that will make the equation work. But if t minus 1 equals 0, that'll also make the equation work. And if we solve, we get 79 over 16. That's the t value that you can plug in there to make the equation work. And if you plug in t equals 1, that'll make the equation work also. So there's actually 2 solutions. But it's very important to remember we have to write units. This is a word problem. Word problems usually have units, so we have to write S for seconds. When you take science courses, S is sufficient for seconds. That's usually what we use to notate seconds. So there's actually 2 places where the rock reaches a height of 85 feet. The reason that is if he throws it up, this guy's standing here, he throws it up, right? Well, 85 feet is here, but it's also here, you see. So this is 1 second, and this is 79 over 16 seconds, whatever, how many seconds that is. You can convert to a mixed number if you really want to, but you don't have to. Okay, so we're done with that part. On to part C. What is the height of the rock at the exact moment that it is released from the sling? So that's going to be really easy. So let's just rewrite that equation. And now we're just going to plug in at the exact moment that it's released from the sling. Well, that's just going to be when t equals 0. So we're going to plug in 0 for t. And we almost don't even need to do the math on this because we can see it's just going to be 6 feet. All these terms here are going to go away. So you don't really have to do a lot of math there, but you do have to show that you're plugging in 0. Okay, part D. How long will the rock be in the air before it lands on the ground? So that's when h is 0. So I'm going to plug in 0 for h in that original equation. And then I'm going to put everything on the right side of the equation because, again, remember, we don't like that negative coefficient in front of the t squared. So now we have a quadratic equation to solve. Again, it's in standard form. Again, if you don't recognize it as a quadratic, then you're not going to be able to solve it. And if you don't put it in standard form, you're not going to be able to solve it. So there's a lot going on here. Now you need to remember that there's different forms of these initial equations. You need to do a lot of practice with those problems that I gave you so that you can recognize how to do these initial forms of these equations. Sometimes there's not going to be a third number. Sometimes there's not going to be a t here. There's just going to be one t squared term. You need to know how to solve in each situation. Okay, so I'm going to try 4t times 4t. I tried that last time. It didn't work, but now maybe I'm going to try it. So what two numbers multiply to -6? I'm just going to try -3 and +2. So now if we FOIL this out, we get 4t squared is F O I L. Add those together, 8t minus 12t is not 95t, so we failed on that one. It's not really a failure, we're just trying things. The number 95 is pretty big, so I'm gonna need a big number here. So because I need such a big number, I think it's actually just going to be 16 again, 16 times 1. I just did that to show you that you can try different ways of doing this. We can also try 2t times 8t, but also I'm going to need the number to get even bigger, so I'm going to try to use 1 times 6 if I can. And so now if we FOIL everything out, F of FOIL, and then 16t times 6, that's, let's see, 96t, and then that's O, and then I is -t, and then L is -6. You add those up, you get 95. Bingo, we got the right number. The problem is we got a positive. We want a negative. But that's okay. All you have to do, if you get the right number but the wrong sign, you just change this to positive and change this to negative. Just flip the signs. So now, if 16t plus 1 is equal to 0, then that makes the equation work. And if t minus 6 is equal to 0, that makes the equation work. But what t value makes 16t plus 1 equal to 0? Where it would be -1 over 16. We don't care about that, because there's no such thing as negative time. So that's an extraneous solution. But here we see that if t equals 6, then that produces a solution that's positive, and we can write an S for seconds, and we're done. It takes 6 seconds for the ball or the rock to get to the ground. And so this guy is standing here again. He throws the rock, or whatever he's throwing. He throws the rock, and it gets here in 6 seconds. And the -1/16 second, that's actually going down to here, but that doesn't exist. It's that would be negative time. Okay, so we're on the last problem now. Sorry this class is going kind of long, but the reason this test is taking so long is because I'm trying to explain everything, you see. You don't have to explain it, you just have to do it, so it's going to take you a lot less time. Okay, the top of a tissue box is rectangular. There's a smaller rectangular opening where the tissue comes out near the center of the top of the box. See, this is where you pull the tissue out. The area of the top of the tissue box is 40 square centimeters more than twice the area of the rectangular opening. So I'm going to highlight that because that's going to be very, very useful. That's going to be our master equation. The length of the opening is 3 centimeters less than the width of the opening. That's also going to be very important. I'm going to highlight that. Find the dimensions of the top of the tissue box. Okay, so I'm going to write my master equation. My master equation is the total area of the top of the tissue box is equal to the area of the inner part. Actually, no. Total area of the top of the tissue box, this is the blue equation, that the area of the top of the tissue box is 40 square centimeters more than twice the area of the rectangular opening. So twice the area of the rectangular opening, I guess I can just say RO for rectangular opening. So it's 40 more than twice the area, so that's what that means there. So that's the blue equation there. That's our master equation. That's going to determine everything. So now we have to write some x's. So I'm going to make this, it says the length of the opening is 3 centimeters less than the width of the opening. So if the width is x, then this is going to be x minus 3. So I had to write that purple part in there, you see. In fact, you know what, I'm going to make that black and then go back over it with green so you know that I got that from that sentence. Okay, so the area of the rectangular opening, that's the middle rectangular part. That's the ARO. That part is going to be really easy. Okay, remember, to find the length, or to find the area of a rectangle, you just take the width and you multiply it by the length. Very easy. Okay, don't make this more difficult than it has to be. You're just taking the length, or excuse me, you're taking the width and multiplying by the length. And so just to be clear about that, I'm going to write brackets. You don't have to write brackets, but I'm just showing you that I'm plugging that in for ARO. The total area, now this is part might be a little intimidating, but all you do is you just take the width. The width is going to be x, so this distance plus this distance plus this distance. That's the total width of the whole top of the box, because now we're going to find the area of the whole thing. So we have to take the width, which is x plus 3.5 plus 3.5. Okay, so x plus 3.5 plus 3.5. I just found the width, and I'm going to now multiply that by the length. Very important to understand, I'm finding AT right now, the total area of the top of the tissue box. So the length is x minus 3. It's this length right here, but I also have to add 2 here and 2 here. So x minus 3 plus 2 plus 2. So plus 2 plus 2. So now if you simplify all that, I get x plus 7 times x plus 1. And then we can kind of just get rid of that. We can get rid of the brackets. We don't really need that. And so all of this stuff here simplified to that. And this stuff here simplified to that. Okay. So now we can FOIL this out, and you can do the inner terms in your head. You know, we don't have time to show all the math on that, but you just FOIL that, add the inner terms up, and you get 8x. Here we have 2x times x is 2x squared. 2x times negative 3 is negative 6x. That's the distributive property. Now, we have a quadratic equation. It's a special equation. It takes special methods to solve. So, I know that because we have a variable squared, a regular variable, and a number with no variable. So we have a quadratic. Now that we know it's a quadratic, we need to put it in standard form, because we can't solve it unless it's in standard form. So I'm going to subtract x squared from both sides, subtract 8x from both sides, subtract 7 from both sides, and there you go. Actually, that's a 40. So that should be 33. Positive 33. All right, so now it's in standard form. We can solve by factoring, which is the only method that we learned in this course. We'll learn other methods in other courses. So that's going to be what two numbers multiply to positive 33 and add up to negative 14. That's going to be negative 11 and negative 3. Those two numbers multiply to 33 and add up to negative 14. So now if x minus 11 is 0, the equation works. But if x minus 3 is 0, the equation also works. So one solution is 11 and the other solution is 3. Now, one of these solutions doesn't make any sense. One of these solutions is extraneous. See if you can figure out which one is extraneous. Well, if you plug in 3 to x minus 3, then that would mean the length of the inner part of the tissue, where the tissue comes out, the tissue box, is 0. If you plug in 3, you get 0. That doesn't make any sense. So that's not going to be a solution. We just cross that out. So x is equal to 11. So now we're going to find the width. The width is equal to that yellow thing there. Plugging in 11. We want the width of the whole thing. That's the yellow part. And so we get 18 centimeters. We'll just rectangle that. And the length is equal to the purple part. Plugging in 11 for x. So that's come from the purple stuff there. And so then we get 12 centimeters. So the width is 18 centimeters, the length is 12 centimeters. So if you got that answer, good job. So that was the class today. I'm sorry that class was a little long, but studying intensifies before a test. If you want to get screenshots of all the work that we did today to help you with your homework and to help you prepare for the exam, this is screenshot number 1 and screenshot number 2 and screenshot number 3 and number 4 and number 5 and number 6 and number 7 and number 8 and number 9, but don't go before you get your homework. Remember, the homework is a practice test. So get screenshots of this practice test. Screenshot number 1, number 2, number 3, number 4, number 5, number 6, number 7, number 8. We have the answers. More answers. Screenshot number 9. And screenshot number 10. Do not go into the next class unless you've done this practice test. And I want you to get an A on the exam. So don't take the exam unless you know how to do every single type of problem. So get that practice test done, and I'll look forward to seeing you in the next class.